Good morning, class. I'm going to try these middle sections again. I had some issues with my iPad, and I actually watched one of my videos and noticed that every time I start with "so." Here we go. So I'm going to try and not start every section with that terminology. Today we're going to be looking at some of the muscle stimulation and how things work. One method of studying muscle function is they actually take a single fiber and they will connect it to an electrical device so they can measure the electrical activity that is produced by that muscle. And when that happens, there's a threshold stimulus. The threshold is the minimum. So in order for your muscle to flex or contract, there has to be a minimum amount of stimulus that activates that to happen. And that is this threshold stimulus. When that happens, the electrical impulse goes through the muscle, calcium ions are released, and that calcium ions are going to activate those cross bridges of thick filaments and thin filaments to connect and actually contract the muscle. So threshold is the minimum amount. And then they can take this electrical current that is measured and they can actually record it on a piece of paper. The response of a single muscle fiber, so that's one fiber, is referred to as a twitch. So when you have an entire muscle contracting, every fiber that is contracting is occurring or having a twitch. Those twitches and those responses can be recorded on a myogram. Myo deals with muscle, and gram is going to be some type of recording. So a myogram is the recording of electrical impulses of the muscle. A latent period we'll look at when the muscle is stimulated. There's a very short period before it actually contracts, and that brief delay is called the latent period. So there's just a brief moment where your muscle waits after it has the stimulus before it actually contracts. The latent period is then followed by the period of contraction and then relaxation. And your muscle has to have some relaxation in order to work efficiently. So if we look at a short portion of a myogram, here I can see right here is where the electrical stimulation has occurred, and here's that short latent period. So very short amount of time where there's a delay. Then the muscle actually contracts, and then the muscle should relax. So if I'm reading a myogram, any upward movement is contraction, any downward movement would be relaxation. When a muscle fiber contracts, it's contracted to its full extent. So I would underline, highlight this, all or none response. A fiber is either fully contracted or it's not contracted at all. So if I go to pick up something light, a piece of paper, I don't need very many fibers. But the few fibers that I use are fully contracted. If I go to lift a table or something very heavy, I'm going to have many, many fibers that are used, and they will all be fully contracted. So each fiber is either fully contracted or it's relaxed. A muscle fiber doesn't partially contract. So your movements depend on how many fibers are actually contracting at one point in time. And also muscle fibers vary in their speed of contraction. There are slow twitch fibers and fast twitch fibers. And your body, sprinters, long distance runners, your body actually has a varying amount of these. Some of you might have more slow twitch fibers, and some of you might have more fast twitch fibers. Also, certain areas of your body might have more of one or the other. And those fibers also, if you're eating chicken or turkey or dark meat and white meat, those fibers also help to lead to the coloring of the muscle. So a muscle will receive a series of stimuli, and basically, so if I'm starting to lift something heavy, those stimuli will become increasingly frequent until it reaches a point where it's unable to relax completely, and then the individual twitches all come together for a summation. So my entire lifting motion would be a summation of all the little individual fibers that have been summated or brought together. If this contraction doesn't relax for some reason, it's called a tetanic contraction. Tetanus, this would, if you have not had your tetanus shot and someone actually develops tetanus, your muscles will contract and they don't relax. Certain animals, sheep, are well known to get tetanus, and their muscles will contract and just become stiff and then they don't relax. A cramp, if you have a muscle cramp, that would be something similar to a tetanic contraction where your muscle does not relax. This increases the force of a contraction for a single muscle fiber. So here's a picture. So here I've got my contract, relax, contract, relax. This would be a summation, so more and more and more fibers are being brought into for help. This would be an example of a tetanic state, where it increases, 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 and then it does not ever relax. So if I can take myograms of your muscles, I can see what's going on. Similar to that, a motor neuron from the nervous system and the muscle fiber both together make up a motor unit. That motor unit will be used to contract, and that's going to happen all at once. An increase in those motor units is called recruitment. So like I said, you might need a few muscle fibers, you might need a lot of muscle fibers. So what happens when I start to lift something heavy, if a few fibers aren't going to work, they're going to recruit more, bring in more muscle fibers to help lift something heavy. Recruitment then will cause an increase in your strength and the strength of the contraction because you have more muscle fibers helping. This is just a picture of a motor unit. You can see the nervous system, the motor neuron coming in, and how it attaches to the muscle fibers. And here, sustained contractions, muscle tone, and you've seen this on people. Some people actually have more natural muscle tone than others. Places you see that are like arms and legs. So muscle tone is a continuous state of sustained contraction of a few motor units. Also, it's very important for posture. If your back muscles completely relaxed, you would have absolutely no posture because they completely let go. So summation and recruitment together can produce a sustained contraction, and muscle tone is an example of that. And I will stop there. Next section we'll look at some smooth muscles.